Today we try to make this.
That better not be my house vacuum.
When you've only got about 2 inches to work with, that half an inch, that counts for something. Hello everyone, and welcome to the next in our series on the CNC router. This is quickly moving from a how do you build it series, and it is sort of migrating into a how do you use the machine. In the last video, you saw that we went in and we actually mounted our safety switch, and we upgraded to a higher powered router in the system. Since then, I have added a vacuum system to try to help vacuum up the dust without me sitting there holding a shop vac at it. And in addition to that, I have leveled out the spoil board. I found out that the workbench was not completely flat, and in the process of bolting down the system, there's a little bit of a sort of a rock in the extrusion rail. So when the spoil board went on top, it wasn't actually completely level. I wound up picking up a micrometer and ran it back and forth across the entire board to see how much variance there was. I debated on whether I should just go ahead and mount the board solid and use my spoil board cleaning bit to just flatten it out versus just putting some shims in there and kind of getting it jacked up. It doesn't have to be perfect, but at the same time, it can cause issues. So right now, I've got it dialed into a place where I think it's pretty good. I'm not going to worry about actually running the spoil board cleaning bit across there to level that out. I'm just going to go with it. Now, the last sign that I cut did have issues related to unlevelness, but that was, I believe, warp in the wood that I was using. So I don't think that was caused by the work bed as much as it was the wood. And finally, the one other additional thing we did was move the home switch for the Z axis. I mounted it in the one place that it looked like you were kind of supposed to, but because there's play, basically it gives you so much clearance after it hits the home switch, it kind of drops back down, that the amount of travel that you could do on your Z was very limited. Honestly, we could only do maybe 2 inches max. Anything thicker than that, you just couldn't even put it on here. So I sort of made a homemade rigged up design and purchased another switch that had a longer throw bar on it, and sort of homemade added a angle piece, 90-degree angle bracket to a wheel, and as you can see, this is some homemade stuff here, but I've been doing it since then and it works perfectly fine. And now when I home my Z, it gets the metal plate right up under the bracket, which it only gained me maybe half an inch, but when you've only got about 2 inches to work with, that half an inch, that counts for something. So even at this, you can see that there's still not a huge amount of space underneath the bit. Now, as I was mentioning, I think one of the reasons that I had issues with my signs that I made, and by issues, I mean the lettering wasn't as perfectly the same depth as it should have been, is because the boards have some warp into them. The hardwood boards that I've been using basically are not completely flat. This one is actually better than the other two were, but if it's not completely flat on the bed and the bed isn't completely flat, that's where you're going to run into that problem. And that's where, in the end, I may wind up still flattening out my spoil board. But for now, I'm going to step up from using a piece of hardwood to a piece of scrap MDF that was laying around from building the top. I kind of hate to use this. It was initially going to be the door to cover my electronics. I don't know if I'm actually even going to build that right now. I may or may not really sure, but I do have some scrap left over there as well. So I think what we're going to do today is actually cut a pattern, an actual 3D pattern as opposed to a sign, into this material, with it being nice and flat. And I actually want to use multiple bits, something I have not done yet. So that is sort of today's plan, is to try to actually cut out a decorative 3D pattern in this MDF board. Okay, so that piece of wood, that piece of MDF is 16.5 by 30 inches, 3/4 inch thick. So let's go ahead and drop that into Aspire and see if we can create a 3D drawing project for that piece of wood. Okay, this part I'm just gonna fast forward through just so you can kind of see it in the background. So the first thing you want to do is go out and find an image. Basically, I went to Google, searched what I wanted to find, hit the image search, and looked through all of the image relief files. Basically free, things that someone has made and posted out there. Hey, this is free for everybody to use. Because it's one of the things you have to worry about, is especially if you're going to be selling stuff, is you don't want to accidentally pick up something that is copyrighted by somebody else. Once you find the image, you basically import it into Aspire, and you have to go through a few motions to kind of get it in the right form so that it can recognize the vectors. Once you've got that there, you can select that and go into the toolpath. You select what type of bit you're going to be using. That way it knows what geometry that bit has. And you calculate the toolpath that it needs to use. And when all that's done, you basically export it out into G-code so that your software program can basically know how to control your CNC machine. Okay, while this thing is thinking, let me sort of fill you in some of the project. And by thinking, I mean she's thinking, and she is thinking slow. So this is starting to become a very interesting project. So long story short, what the plan is these are the 3 bits that we are going to be using. We're going to start off with a 1/4 inch bit to do a roughing cut. Then we're going to step down to an 1/8 inch bit for additional roughing, and then finally a tapered bit to get the fine detail. If this actually winds up being something pretty enough that I want to keep it, then maybe I'll cut the edges off. It's really just a test right now to see how well this is going to do. And with it being so intricate on that one piece that's running right now, that's definitely going to give us a lot of movement. Oh, either this computer is way slower than I thought, or oh my God, what have I bitten off? This thing is going to take like hours to cut. This may not end well, y'all. This may not end well. And with all 3 of those completed, you can now see what the toolpath will look like and how much finer the detail is through each of those toolpaths. Zero everything. And now we're good. Okay, we have replaced our 1/4 inch bit with a 1/8 inch bit, and we are ready to run through basically the exact same cycle again using the next file. So let's get going. Okay, and once that was complete, I went ahead and switched over to the tapered end mill to do the final finishing cut. As you can see here, this one was going way slower than the other one. In fact, I wound up speeding it up close to 400% faster beyond what the default rate was. And still, after it ran back and forth maybe 10, 20 times, it looked like it was just sitting in the exact same channel. So I got curious. I went ahead and stopped it thinking that something was broken just because this thing was huge. We're talking 14 million lines of G-code. So I went back into Aspire and pulled up that finishing cut and took a look at it. And yeah, 891 hours estimated cut time. And that's at 100 millimeters per second, 10 centimeters per second, and I'm looking at 891 hours. So, in theory, if I had let it run for, that is basically 37 straight days running 24/7. Yeah, this is not worth 37 days of listening to this thing run just for a test project. I'm going to call the overall project a success. I wanted to test out the machine, something that would really put it through its paces, a lot of XYZ movement, a lot of G-code, and I was able to do that. It looks like everything should work perfectly fine. There were a couple instances looking at the cuts where it seemed like a couple passes were maybe one revolution lower than they should have been. I don't know if that's a hardware or software issue, not really sure. But for the kind of stuff I'm going to be doing 99% of the time right now, which is primarily going to be sign making and adding small text to things in the projects that I want to work on, this should work perfectly fine. So while this piece was a little bit of a failure in that I couldn't get the finishing one in, the overall project was a success. Now let me give you an idea, a little bit closer shot of what this project actually wound up looking like in the end. Okay, as you can see, overall, you can kind of get an idea of what the project looks like. It's basically, you can see the overall layout of the design, and probably the farther back you get, the better this will look. For now, it's going to go on my wall just to demonstrate, hey, these are all, this is where I started. This is my first piece. So I'm not going to throw it away, but I'm not going to try to do any stain or anything to this to make it look better. I'm going to go ahead and just unbolt it from the table, add it to the wall, and move on with some other projects.